All right, we're going to go ahead and kick off. Good morning, good afternoon, good evening. Welcome to the Fort Wayne Metals Wire Solutions for Braiding webinar. We are very excited to be with you all today. Thank you for joining us. We have the honor of kicking off a new Fort Wayne Metals 6-part webinar series where you will have the chance to listen to our cross-functional groups within the organization share current capabilities, what's new, what's coming, all things Fort Wayne Metals. My name is Lindsay Potts. I am the Senior Product Manager for our core segment here at Fort Wayne Metals. I've been with the company almost 9 years, and along with my team, I help support our stainless round, flat, shaped, and SLT wire, as well as our bar and titanium products. Today, you will be hearing from several members of our core segment team as we dive into stainless round wire, our newest condition offering of ultra strength materials. We'll also touch on multi-end spooling capabilities and considerations, followed up by our flat wire and the different surface finishes that we currently offer. So before we get started, just a few housekeeping notes, and then we'll introduce the team with you here today. Your microphones and cameras have been disabled. However, you will have the ability to post reactions. So if you like the content that you're hearing, or maybe you are currently using one of these products in one of your applications today, give us a like or a thumbs up. We'd certainly love to hear from you guys. We will have time at the end of our presentation to answer your questions. So please feel free to post those at any time in the Q&A section. We'll be sure to cover those at the end of our presentation. And lastly, please mark your calendars for Monday, July 30th for our Part 2 series, where our nitinol team will be talking about our nitinol melt capabilities. So keep an eye out on our LinkedIn page for the link to register for that event. Again, Monday, July 30th. And now, without further ado, let's meet the speakers that are here to share more with you today.
Hello, everybody. I am Austin Roberts. I'm the product manager over our stainless steel flat shaped and SLT material. And I've been with Fort Wayne Metals just under 3 years now.
Hello, everybody. My name is Brittany Billings, and I am the product manager over our stainless steel round wire. I've been with Fort Wayne Metals for 6 years.
Hello, everyone. I am Blake Nickel. I'm the senior process engineer over our flat, shaped, and SLT products, and been with the company just about 7 years.
Hello, everyone. I'm Garrett McCord. I'm the process engineer over our fine wire, stainless steel round wire side of things. I've been with the company for about 10 years.
Hi, my name is Ross Dillon. I'm a senior associate engineer, primarily working in R&D. And I have been with Fort Wayne Metals for going on 18 years. So.
All right, thank you guys. And we will kick it off with our round wire.
Hello, everybody. I'm going to be covering our round wire. Some of these things you may be familiar with, some may be new to you. So if you have any questions, please feel free as I go to ask questions. Here you can see the various materials that Fort Wayne Metals produces round wire in. For today's presentation, we will be focusing on stainless steel and tungsten. However, if you're interested in high performance alloys, nitinol, titanium, please keep an eye out for the additional webinars, which will focus on these areas. Our size range is 0005 to 0.55 inches for round wire. However, anything above 0.0625 would generally be produced as bar rather than round wire on a spool. The stainless steel alloys that we process are 302, 304 LV, 304V, 316 LVM, and custom 455. And we offer a large range of conditions. So starting at the top, you'll see our new ultra strength condition. That's going to be focused on today. As you move down the list through high tens, spring, hard, and finally to annealed, the tensile of those are going to decrease as we go down and the elongation will increase. You can see our top four are available only in 304V with a few exceptions, while spring and below are for most stainless steel alloys. And here you can see our reference mechanical values. So starting at the top, you'll see our fully annealed condition. That goes from about 85 KSI to 130, dependent on the alloy. And then the smaller the wire diameter is, the higher the tensile range is going to be. Moving down to our spring condition, these are also dependent on the size. For 304V and 302, we're going to reference ASTM on those, and those will go along with those values. For 316 LVM, the max tensile capability is going to be about 270, and then will lower as it increases. And for 304 LV, the max is going to be about 310, and that will also lower as the size increases. In our high 10 condition, that's going to be available for 304V, and that's up to about 0.3 in size. The tensile will range from 440 KSI nominal and fine wire, and then we'll go down to about 330 nominal at higher sizes. And then the ultra strength, so this is just speaking to our stainless steel 304V. Ross is going to cover our tungsten, but the size is 0005 to 006, and the tensile range is going to be about 470 to 500 KSI nominal. And then we always like to say we can hit values in between these ranges, so you don't have to be exactly in these ranges here. If there is a desired tensile target that's in between these, it's best to let us know that target, and then we can advise the internal condition that's going to be the best fit for you. So now we'll move on to our ultra strength. And our ultra strength condition is offered in two different alloys, tungsten and 304V. First, we are going to talk about tungsten, and I will pass it over to Ross for that.
Ross, you're muted.
Apologies. We're really excited to share the latest development in ultra strength tungsten, and we believe it could be a pretty good fit potentially for your applications. So overall, the motivation. So the motivation behind creating ultra strength materials, specifically tungsten and 304V, really comes down to the overall device downsizing. So as you design and build smaller devices, unfortunately, there's some mechanical performance loss just due to the sizes being used. So if we can provide a superior strength, this may help mitigate some of that loss that you see. Also, in surgical robotics, they can be very demanding on the cable systems, and primarily those cable systems are made of stainless steel or tungsten. So if we can enhance the resistance to deformation, it can significantly extend the cycle life of those cables, and ultimately give better and more enhanced, reliable experiences for our patients. So let's share the diameter ranges we can produce with the ultra strength, and that will run at, say, 5/1000ths of an inch down to 5/10,000ths of an inch, where tensile strengths come to about 520 to 800 plus KSI. And it's good to note with those strengths, we're still able to maintain pretty good ductility at 2 to 4%. If you look at the right of your screen, the stress strain curve between foreign metals material and conventionally processed tungsten, you'll see a clear difference there. But not only that, it's good to note what's the area underneath those curves, which is the material's toughness. That is the ability of the material to absorb energy before failure. And if you can see and you can see the clear difference between the conventional and foreign metals high strength, which with foreign metals, it's about 3 times more energy absorption before failure than conventionally processed tungsten. As I noted, the 800 plus, this is where that plus comes in. we're able to almost hit 1,000,000 PSI at 12.7 micron in diameter. And still, again, maintaining excellent elongation. So this is basically the highest recorded strength that we could find for commercially pure tungsten. So potential applications, obviously, we just mentioned surgical robotics. If we can provide a harder material that correlates to better wear resistance, and it's less prone for plastic deformation. And downsizing cable configurations also could lead to better dexterity and device manipulation, catheter reinforcement. And then an area we are looking into is guide wires. So guide wire diameters. If you can provide an ultra strength, ultra stiff guide wire that could potentially aid in chronic total occlusions, where you could use that guide wire to pierce through an occlusion or occluded artery, could be very beneficial. So with that, I will hand it over to Garrett to talk about the 304V.
Thank you. Like Ross said, I'll talk a little bit about 304V Ultra Strength. The motivation for Ultra Strength 304V is generally the same as tungsten Ultra Strength. Again, we're looking to downsize some devices. An example is catheter reinforcement. If we can provide a stronger material, it may be the tipping point where you can make your catheter ID a little bit bigger so you can pull more through. But just overall strength in strains and braids as well could be a good benefit, and it also adds to the strength fatigue as well. To go into the stress strain curve for 304V Ultra Strength, the difference in strength isn't as drastic as the tungsten is. However, with typical high 10 material, which was our previous highest strength material on 304V, we see about a 30 to 50 KSI jump in tensile strength. So the sizes that this is available for is about a half a thou up to 6 thou inches. And we've been able to reach about 500 KSI while still maintaining pretty good ductility of 2%, which is very close to high 10 condition as well. Some of the potential applications would be catheter reinforcement. There could be some potential with springs with added stiffness, as well as guide wires, just the same as tungsten. The extra stiffness could be the thing that makes us able to go further into the body. And then I'm also going to talk a little bit about the multi-end spooling process, which is just the act of spooling multiple wires onto a single, usually a braider bobbin. So Fort Wayne Metals is capable of running up to 9 ends or wires on a spool. With our Steger style braider bobbins, which we'll go over the spool types here in a little bit. Usually we run about 1 thou to 3 thousandths in diameter. And then from 3 thousandths to 8 thousandths, that would typically go on a Wardwell or a New England style braider bobbin. But if there's anything outside of those ranges that you guys would like to try, just ask. We're always willing to look into other things. And in general, any alloy can be spooled with multiple ends, although typically it's going to be your 300 series stainless alloys and similar. And it's also typically done with round wire, but it can be investigated with other configurations like a strand or cable or a flat wire. Some difficulties or considerations to think about whenever you're first setting multi-end products up. The main one is braiding tension. It's best practice to spool the material with slightly more tension than you're actually braiding it with, which eliminates material digging into other layers, which can contribute to breakages during braiding. So whenever you guys are setting up your parts initially, going onto a braider, let us know your braiding tension or your spring combination so we can calculate the theoretical braiding tension so we can have our best chance for success from the start. And then also handling is a big consideration when ordering multi-end material. Generally, the complexity and the difficulty to handle goes up with the more wires you put on a bobbin, as well as whenever you increase the size along with that. So if tension is lost via handling or a break in the braider, this can cause some serious difficulties when trying to braid. So sometimes whenever there's a break in the braider, the bobbins can be attempted to save. So if you're attempting to save the bobbin, we need to make sure that the wire is actually in wrap. And by that just means that all the wires are the exact same length on the braider bobbin. So if you take one loop off of a singular wire and then the others have those loops still on there, the length is effectively different. That will cause crossovers and breakages ultimately in the braider. And then if that's ever a concern or you guys would like to learn how to do that, let 4M Metals know and we can try to get you a demonstration on how to properly check the spools in wrap or just untangle a spool in general. To go into the spool choice considerations, we have 3 different types of Steger braider bobbins, and that's the ones we'll focus on. So we have the Enduro bobbin, the medium hub bobbin, and the large hub bobbin. This fits the KL80 carrier style. So the Enduro bobbin, that is ultimately the most forgiving bobbin when it comes to unspooling wire in most situations. However, this can cause difficulties for larger wires and multiple ends, and we generally don't recommend going over 3 ends, and we kind of stop at the 003 multi-end part for the Enduro bobbin. So if there's ever any question on what bobbin type should be used, just ask 4M Metals. We'll give you some recommendations. The medium hub bobbin, that one can hold the most footage for the most uptime on your braiders. However, the trade-off is that the spool is not as as sound with the strength. And then the large hub bobbin, that can hold the least amount of footage, but they're the most robust and repeatable when it comes to spool integrity. And we're always recommending that we use the smallest amount of footage possible while we're still keeping the braider efficient enough. This helps reduce the material risk if the bobbin does break, and then also helps us to reduce the amount of spooling issues. And then the final difficulty or consideration that comes with multiple ends to think about is that material with multiple ends will have catenary sag, or otherwise known as droop between wires. This will show itself as just 1 or 2 wires drooping slightly more than the other wires in the bunch whenever you put slight tension on it. This is mostly present due to spooling complexity and difficulties, but this actually can be affected with braiding tension in the form of reducing or adding to it. So if you ever see issues with catenary sag, upping braiding tension can help, but that also comes with trade-offs as well. Just something to look at. As usual, additional ends and larger sizes of wire will add into this complexity with catenary sag. So the more collaboration we have at the start with you guys to set up the part with the correct tension and the correct bobbin will allow us to really set you guys up for success. And then also the feedback coming after you guys try your initial braids also helps greatly with success. And with that, I will pass it over to the flat wire group.
All right. Hello again, everybody. I'm going to be going into further detail on just the general capabilities of flat wire. So Fort Wayne Metals has 2 forms of flat wire. We have rolled flat wire and drawn flat wire. So rolled flat wire is our most common product that we produce most of the time. However, we do have drawn flat wire that provides tighter tolerances for width and thickness, and then also a more consistent size throughout. Historically, drawn flat wire has been able to hold considerably tighter tolerances for the width and thickness. However, with new advancements in processing and machine capabilities, that gap has really tightened up. Now rolled flat wire is very comparable when it comes to tolerances with drawn flat wire. And then on the material side of things, almost any material that Fort Wayne Metals can produce as round wire, we can also produce as flat wire. There are some instances where due to certain alloy properties, the material doesn't really roll and produce product up to Fort Wayne Metals quality standards. But feel free to reach out and ask, and we'll gladly look into any additional alloys outside of stainless steel. But for today, we're going to be primarily talking about stainless steel flat wire. So the size range offered for rolled flat wire is 3/05 inches by 2/15, and then up to 050 by 080. We can provide material larger than this. However, anything over that 080 inch width would be considered rolled strip and processes on different equipment. The width to thickness ratio has a max of 10:1 and a minimum of 2:1. Just wanted to throw out that when you do get towards the lower end of that ratio, there is a possibility of poor cast and camber as well as straightness concerns, mostly due to the material being so close to square that sometimes it'll want to roll on the spool, kind of spool on the opposite side that we traditionally want. Standard tolerances for rolled flat wire are plus or minus 10%, and then the tight tolerance being plus or minus 5%, with the tightest of plus or minus 0.302 on the thickness and plus or minus 0.303 on the width. Just know we're always pushing to improve our capabilities. So if you guys have a size, ratio, tolerance, anything that's outside of this range, please feel free to reach out to us. Our team very much enjoys pushing the limits and just seeing what the next and best thing we can do is. So please don't hesitate to reach out. And then again, I'll slightly touch on packaging options, very similar to what Garrett touched on earlier. 4N Metals has patented the Endura bobbin. It has a 45-degree flange. Really leads to less snags, tangles, and easier payoff for rolled flat wire versus Steger style. The ratchet and bore are the same as the Steger style, so it'll fit all the equipment that you're currently used to. And then the Endura holds up to 80% footage-wise is what the Steger style does. So very minimal loss there on the amount of material we can hold. And then let us know if you guys haven't used the Endura bobbins before. We'll gladly work with you to get you either just some sample bobbins or get you some of your material on the Enduras. That way you can try them out on your braiders and let us know what you think. Pass it over to Blake.
Yeah, so I'm going to be reiterating a lot of the same things kind of Garrett talked to. Flatware has a lot of the same practices with winding and spooling as well. The biggest thing I can always say is work with us up front. A mismatch in tension can lead to a lot of poor issues with braiding. Garrett, like I said it as well. If you're braiding with more tension than we're spooling, you're going to have a lot more dig-ins, wire breaks, kinks, snags, things that are just going to make the process not very efficient. On the reverse end, it's a balancing game too. We want to make sure we're not applying too much tension, or we're going to lead to wire damage, wrapping or warping of the bobbin. So some of the best practices is just providing that braiding tension up front will lead to better success with 4N Metals and your product as well. So always feel free to reach out to us. We will recommend what tensions we can do and let us know what your goals are with that. So we also are trying to explore the ultra strength process as well with flat wire. One thing just to kind of reiterate at the start is flat wire and round wire have a different kind of cold work. So anytime we're rolling flat wire, we're going to lose strength from our incoming round wire. So if we're getting 500 KSI, we'll probably lose about 50 KSI approximately. It just depends on the condition and what we're trying to manufacture. And this is going to be available, this high strength condition, from half a thou by 0025, from 3 thou by 9 thou as well. Again, just keep reiterating, we're always willing to explore outside those ranges as well. Just kind of let us know what you're looking for and what applications you're working with. Just to kind of give some equivalencies on tensile as well. Our highest condition we used to have is high 10, where we were targeting around the 400 KSI depending on size. As you get the size bigger, the tensile will decrease a little bit on size. Then we also have our ultra strength, which we're now exploring with flat wire as well, where we've been seeing some tensile strengths from 450, 440, and almost getting up to 460 KSI as well. So this is still early on in development. We've only done a handful of sizes, but we would love to keep trying different sizes and working with different customers on this. Same kind of applications and improvements we can see with round wire. Even with the benefit of flat wire downsizing that profile even more. So. And then we're going to talk a little bit about flat wire surface finishes as well. We offer a lot of different surface finishes and kind of for different applications. The biggest one being kind of coating adhesion, which we'll talk about a little bit. But the 3 surface finishes that we offer are bright, semi-bright, and rough rolled. Bright being the everyday standard surface that we produce, and we always tried kind of pride ourselves on. Then we have semi-bright, which is just a little bit more dull. You can even see in the picture that with even being side by side, there's not that much of different comparable difference. Where you see it is a little bit under the scope, under higher magnification. Ruffled, you'll start seeing that dull appearance on the wire. And just kind of talking about some of the RAs, our bright is typically usually under 1 RA, but with all wire sizes, it's usually under 2 RA. Semi-bright being kind of in the middle there, 2 to 5 RA, and our ruffled being typically over 5 RA. Roughnesses will kind of vary depending on the wire size and our width to thickness ratio. When I say that, yeah, our width divided by our thickness. So it will kind of vary depending on what size we're working on. We did find that this is not really ideal for sizes under 2 thou by 5 thou, where we kind of start seeing that the texture of semi-bright and rough rolled kind of outpowers the size of the wire. So the grain is just a little bit too large on those products. Just wanted to show some quick examples. So this is just our bright surface finish with a 3D surface roughness testing. The one I really want to highlight is the picture on the bottom right, where you can see that smooth, even finish. This one's reporting out our RMS of 0.3. We'll typically report out RAs as well. And then on our next one, which is going to be our semi-bright, you can see there's a little bit obviously more texture, a higher RMS value here as well, where you can see some of those valleys and ridges and additional texture that can help with some of that coating adhesion. We also wanted to show just the difference, even under magnification. There's just that slight noticeable difference. Really, with the biggest selling point for semi-bright is it's a more consistent surface finish is kind of the biggest thing, and it's a little bit easier to manufacture as well. So it's a benefit from if it's not going to be trying to say if you're going to be coating the product anyway, a lot of times you're not going to see that surface finish either way. Produces a more consistent surface where that bright surface might not even be needed, which is going to be coming at a higher cost. The other thing we kind of been exploring too is we were looking at doing multi or hybrid surface trials as well. So this can probably apply to coiling just as much as braiding as well, where we are using different rolls on different sides of the wire. So we're doing more of a rough rolled on one side and more of a bright on the other. Where the hopes of this is actually being able to take your mandrel or decoring the wire after your braiding or coiling operation with a little bit less friction on the inner side of the wire, where you have that rougher surface on the outside for more your coating adhesion or what other application it might fit with a rougher surface. We've trialed just a couple different sizes, still early on, trying to see what the market says and kind of what applications are out there. We're willing to do different trials for it. So if you're interested in this, just reach out and we're willing to work with you on it. So. And then even next, another one that we are also exploring is wet blasted material. So we're kind of limited on what our roughness we can get with our rough rolling applications, where we'd have to get a different equipment to keep increasing that RA. So we do have very limited capacity right now with this machinery, but it's something that we want to continue to invest in if there is a market out there for it. We can reach RAs of over 10. This can go for round wire, flat wire, probably even other applications as well. Like I said, limited availability right now, but we're seeing really good RA values and a very consistent surface roughness that is can greatly help coating adhesion. Thank you.
All right, thank you all. With that, we will hop over to the Q&A. If anybody has any questions, please feel free to put those in the Q&A. The team here with you today is more than happy to answer those. All right. Well, hopefully we answered most of your questions in the slides and presentation from our team. If you guys do have any additional questions, Here are our contact information. Please feel free to reach out. Myself, Austin, Brittany, we are more than willing to get you in the right hands here, or you can always reach out to your Fort Wayne Metals sales reps that are territorial based. Looks like we may have one here. Okay, so what options of reel do you have for 304V wires?
So that really depends on size in general. We have what ranges from very small spools that fit 1,000th wire up to 72,000th wire. So we have a lot of the standard DIN spools, up to 22-inch in diameter spools that are about 14 inches long. So it really depends on what size you're going for. So if you do have a specific size, please ask, and we can get you a recommendation for that.
Thank you, Garrett. Another question is there a cost difference between high 10 and ultra strength? I can go ahead and answer that one. There is. The ultra strength, I guess I can't share a specific percentage with you of increase, but if you guys have a diameter range within our round wire, whether that's 304V or tungsten, we'd be more than happy to provide you guys with a quote to compare the price difference there. So please reach out. That would likely go to myself or Brittany. The next one is, how does surface finish affect camber?
So we actually typically see a better camber on flat wire with a rougher surface. It's very little difference, but we're going to be somewhat comparable, but we have actually seen improvements with a rougher surface and camber. So.
Thank you, Blake. All right. Well, we greatly appreciate you guys joining us today. I apologize if I said June 30th for our Night and All webinar. That is July 30th. So please mark your calendars for that and keep an eye out on our LinkedIn page for the link to register for that event. Again, we greatly appreciate you guys being here. We hope you guys enjoy the rest of your day, and please reach out and contact us if we can further help you in any ways. Thank you.